let's get into the European scientific revolution and European exploration. Sometimes I like to start with just a snappy definition because that definition is going to hopefully allow you to hang all future knowledge and stories that we get into here into that. So scientific revolution, European scientific revolution, if I had to define it, it would be this. It's this sort of broad period in the 15, 16, 1700s in Europe where intellectuals, again, not everyday people, just like with the Renaissance, if you're a common everyday person plowing a field or tending flocks of sheep, cows, and chickens, your life is not consumed by what's going on here. It later on will be, but at the moment probably not. Intellectuals and scholars will begin to question accepted beliefs, particularly in matters of religion, and develop new methods for explaining the natural world based on a couple of things, and I really want to take these points home. Their new methodology that they're going to use to draw up new explanations about the natural world, it's going to be based on, number one, experimentation. Run the experiment to discern truth. Don't just go with what somebody told you or what you read in a book or what some famous person that has a lot of gravitas and authority says. Run an experiment. If it can't be tested, we don't really care as much. Replicability. Can you run that experiment in different parts of the world? Can you explain it to someone? Could they run it themselves? And finally, if you've done that and they've done that, you should put out your findings in an open, easily accessible journal where anybody in the world can read it and subject it to what we call peer review, which is probably the most important thing when it comes to the scientific method, because it's the one thing that allows us to find flaws in other people's work. You have to publish what you find. So that's the definition of what this scientific revolution is. It's not a clear bookend. This is when it starts, this is when it ends. It's not like a war we can get our minds around. It's this broad span of time, just like the Renaissance, that looking back, historians are able to identify and see some big trends. So let me give you some big trends of my own here. If you were looking back to this time period in European history, Europe would not be the place you'd probably want to live. I wouldn't want to live in this time period anywhere, but if I had to, it wouldn't be Europe, because Europe is a relative backwater for learning. The Middle Ages still dominated, a lot of medieval thinking still dominated people's life, especially the ordinary everyday people, even if the Renaissance had maybe upped the game a little bit amongst intellectuals. The best minds, going back to the Middle Ages and still to a large extent, they go into the church. They go into religious orders. This is where you went if you wanted an education in the Middle Ages. Not that that is by itself a problem, but it kind of isolated and cordoned off intellectual ability in the sense that you were devoting large sums of your time to learning Latin and Greek and arguing Scripture. Not that those weren't worthy endeavors of the time, but it meant you weren't running experiments to understand the natural world. It means you weren't engaging in business practices that could advance all sorts of trade and commerce and so forth. So a lot of the best minds were kind of isolated in one area of society. And also there's limited social space to even challenge Scripture. Let's say you were an educated monk or bishop or priest or somebody that was learned in Latin and Greek. You'd spend most of your time in a scholastic environment arguing text, religious text, amongst other members of the clergy. And yeah, you could disagree, and there would be fervent disagreements there, but that's all you'd be doing. You wouldn't go beyond those parameters. And finally, we have the Renaissance, which we talked about on Friday, and this idea of humanism. This is at the core of a new way of thinking. Humanism really is the key that unlocks a lot of what we're going to be talking about here. And that, remember, is that idea that individual achievement and worldly concern should be our focus. It's driving a newfound optimism, an idea that the world and the natural world and knowledge can be comprehensible, not just by intellectuals, not just by people who study Scripture, but by the everyday person. That's a very optimistic thing that we often take for granted now. It wasn't the case back then. The printing press is going to be tremendously transformative. It's going to allow a new flow of ideas. Just to make a parallel with you that your life a little bit overlapped with, maybe yours not so much, certainly mine and some of the other staff members, the internet, in a small way, is a little bit of a parallel with what the printing press does. There was a time period, maybe sometime around the late 90s, early 2000s, where it suddenly became possible. If you had an idea, you put it on the internet. And maybe nobody would read it, but maybe somebody would. And then maybe they'd share it with somebody else, and then they'd share it with somebody else. And all of a sudden, someone who didn't have a lot of social status or real backing or any way of getting access to a platform could suddenly have a voice. And this is what the printing press does in the 14, 15, 1600s in Europe. It gives a voice to people who previously didn't really have one. So if you had an idea and you could compete in the realm of ideas, people would start taking you seriously. Finally, voyages of exploration. The European explorers that you probably talked about in US 1, they're going to go out and they're going to discover new lands and new materials, and they're going to bring them back, and it's going to shake up the conceptual foundations that Europeans have about themselves and their role in the world. Medieval view of knowledge. I'm going to breeze through this because I kind of talked about it on Friday. But knowledge, what we knew to be true, what we would bank on, what our important people in society would fall back on when they were explaining stuff to everyone else, it was based really in this idea of Scripture as the foundation. The Bible, the religious text, which of course is rooted in Judaism, of course, but then there's a whole litany of Christian writings that they would be familiar with. Scripture is the authority. The thinkers of the time, they were not unfamiliar with the writings of the Greeks and the Romans. They would have been very familiar with Plato and Aristotle, and a lot of the early church fathers would have engaged with those writings. They would have found them fascinating, but they would have had a little bit of caution. They would have cautiously embraced those writings because although the Roman senator Cicero or Plato or Aristotle may have been very learned men in their time, they were also not Christians. They were also pagans. They were living in Greek and Roman pagan world. And there was a fear amongst intellectuals in the church at the time that if you got too into your Cicero or your Aristotle, that you would contaminate your devotion and fidelity to Christianity. So the church is going to be the authority on matters of scientific inquiry for the most part. So I'm going to familiarize you with a couple big trends here that will reassert themselves in some of these small little clips we see before the end of class. There's an emerging way of thinking amongst intellectuals in Europe at this time. One of these ways of thinking, or methodologies, is called the scientific method. You may have a little familiarity with this from Science 9, Science 10, 8th grade science. I'm sure you would have encountered that term, and maybe you could explain it. And empiricism, another very important value concept that's going to anchor our new way of going about knowledge if you live during the scientific revolution. So philosophers and scientists, and these, by the way, are not mutually exclusive categories. You could be a philosopher on Sunday, and you could be a theologian on Sunday and be interacting with the Bible and religious scripture, and then on Monday, Tuesday, Wednesday, you could be rolling with science experiments and, looking at celestial bodies with telescopes and writing about that and penning a letter to a friend about some biology experiment you're thinking of. These categories weren't nearly as firm as they are today, where we have these really stark disciplinary boundaries. So they begin to challenge the methods for going about finding truth and knowledge. Remember, the medieval worldview of knowledge was you start with Scripture and you reason your way from there. This new way really goes against that. Let me talk about the scientific method first. Scientific method is rooted in this idea that we should seek to understand the world by not starting with some preconceived notion, not starting with a premise that has been elaborated in Scripture, but we should observe. We should then question, maybe pose many questions. And then maybe after a period of observation and questioning, we formulate a hypothesis. We try to establish some sort of predictive statement about if this happens, then this will happen. And then, and here's the interesting part, you run the experiment. And if you don't run the experiment, nothing else matters, because the experiment is what's going to get you closer to the pathway of truth. and it's expected then that you can replicate the experiment, that you can write a letter to somebody 100 miles away and that they can replicate the experiment. And finally, that you publish it, that you subject it to peer review. You open up all your findings. You have nothing to hide. Tell exactly what you did, and other people will try and poke holes in it. It's that rigorous process of the scientific method where everybody's trying to climb the mountain of truth and everybody's trying to kind of poke holes in what the next person has established. But by doing so, you set off a very fierce competition that usually leads to true ideas rising and false ideas collapsing. Secondly, empiricism. This is a very important concept that all of, I guess you could say, our medicine, our treatment of disease, our kind of understanding for how we cope with medical problems, it's really based in this. Empiricism is this kind of idea that knowledge, the stuff we really bank on, comes through our natural senses and through our experiences. And most importantly, empiricists would say, you not only have to have these things come through your natural senses and experiences, but they must be subject to testing. If you can't test them, it doesn't matter. What that means, if you think about empiricism, it means that supernatural explanations or seemingly magical explanations for why things happen, if those aren't subject to a test, we kind of have to discount them because they can't be tested. So that's that idea of empiricism and the scientific method. Both these things together, they begin to challenge that old conception of knowledge. Some big values that you're going to see increasingly more important in European intellectual communities. There's a greater value on doubt. Doubt is kind of celebrated. The philosopher Descartes really going to say, doubt everything. Skepticism, the idea of limiting your preconceptions. Don't impose upon the natural world some idea that you read in a book or somebody told you. Observe it as it actually is. Don't project your own thinking on it and try to run the experiment. Subjecting your theories and ideas to a test. Two individuals, you don't necessarily have to remember their names, but I just want to elevate them up a bit here because they played a big role in this. Francis Bacon and René Descartes. Both are going to pick up on these threads of scientific method and empiricism. In fact, Bacon's going to be called the father of the scientific method in a lot of ways. But I want you to also remember that these Europeans are not doing something unheard of. There had been similar kind of methodologies for establishing truth, like kind of a proto-scientific method in the Islamic worlds for hundreds of years prior to this. A number of Muslim scholars are going to write about this, and then later on, through sort of the intellectual communities of the day, Bacon and Descartes are also going to run with this idea. So again, both of these individuals are going to get you to that idea of the scientific method. I'm going to move through a couple broad categories here. I don't want to focus on the names so much, although these names and stories we're going to hopefully investigate, and they're very interesting in their own right. But these broad categories, firstly I'm going to talk about the shaking up of how people saw the universe as being arranged. I'm going to then talk about biology and chemistry, some big breakthroughs there. And then I also want to talk about disease and philosophy. Scientific revolution is going to shake up all of these areas and going to put humanity, put Europe in a fundamentally different position than when it started. The first individual I want to bring up, Nicholas Copernicus. You've probably had a little bit of familiarity with him, possibly if you've explored these concepts before. Copernicus is kind of the founder of what we call the heliocentric view of the universe. The idea that the solar system has the sun at the center and that a collection of planetary bodies orbit that sun and move in predictable, measurable fashion. The previous belief that Copernicus in his writings will challenge is that of geocentricity. The church and scripture had argued that the earth was the center of the universe and that planetary celestial bodies moved around the earth. Copernicus is going to question that through his use of a telescope and studying the movements of the planets. He's going to challenge that idea. Later on, Galileo Galilei, the Italian astronomer, is going to back up and confirm what Copernicus finds. Copernicus himself doesn't really get to revel in the glory of this achievement because he realizes it's controversial and he publishes at his death. So his writings get picked up, and later on Galileo is going to confirm them, and he's going to come into massive conflict with the church. Mr. Ellenbecker is going to talk about that story on Friday. The more towering figure, perhaps, than either of these, the one who's most well known, is Isaac Newton, the English physicist, mathematician. Add about 6 other things to that list, probably. He's going to outline, not outlaw, the laws of gravity. He's going to do a lot of experimentation with light refraction. And we're going to see a clip here just to kind of illuminate Newton for you. But ultimately, there's going to be a new outlook within intellectual communities in Europe. And that is, there's going to be a newfound confidence that the universe is comprehensible. We can understand it. It's not something that's beyond our boundaries. We may not know it now, but we have a methodology, an increasingly more effective methodology for finding true things and discarding false things, finding what's reliable and discarding what's not reliable, and that it should be investigated. So I want to just show you this short little clip on Newton. So that is a very key idea I want you to appreciate about the scientific revolution and broadly the European Enlightenment, is this newfound confidence that you should not only try to figure out the world, but that you should expect to share that with people. This is, I guess, kind of like carrying around those models of the solar system would kind of be the equivalent of like PBS Kids, getting that knowledge diffused out to young people and get them curious, get them asking questions. And this is a very Enlightenment scientific idea. And it's rooted in a sort of confidence that ordinary people can be educated, that they can be improved upon, and that wasn't necessarily the case if you go back to the medieval conception of knowledge. The second category I'd like to just investigate here is biology and chemistry. 2 big breakthroughs. There are many, but I'm going to isolate it to just these 2. One is the discovery of microbial life. This is when I talked about impacting our lives today. If we don't have an understanding of microbial life, almost all of us, our health is going to be at risk, because how often have we become sick with things that are from microscopic bacteria that can be deadly, can be lethal, and can be treated with antibiotics and antiseptics and all of those things. Also, the understanding of oxygen and carbon dioxide. Both of these, again, lay the basis for so much other scientific knowledge. It becomes this big scaffold that you can hold new things on. So I want to show you this little look into the discovery of microbial life. There's going to be 2 individuals that are going to be referenced in here, one more than the other. Robert Hooke, the English scientist, philosopher, he does a lot of things actually, and Antony von Leeuwenhoek, who's going to be a Dutch thinker. He's going to be a lens maker, a lens crafter, if you will. But he's going to be the first person, I find this just startling because it's not until the 1670s, the first person to actually observe microscopic life. And he's going to do so with his own homemade lenses. And I'm going to let this clip kind of bring it to life for you here. But I want you to just think about how this fits in the broader context of sudden discovery and the illumination of an entirely new world that can be explored.
When animals...
After this commercial.
When animals first evolved, life's cake.
From the time humans evolved, bacteria and other microbes would have colonized every...
I'll just pick up there because I think that's an important kind of frame for understanding. Once you begin to understand bacteria, you understand probably the most significant force in human history. And that is when disease sweeps through a community and wipes out towns and villages and thousands of people, or when it impairs an army, or when it debilitates a population in some way, history changes. How much of history can just be reduced to one group of people getting smallpox and another group not getting it? So that discovery, that illumination that Leeuwenhoek is going to discover in the 1670s is going to have profound implications. Again, just look no further than the last time you were prescribed antibiotics. That is basically dealing with microorganisms, diseases that can be lethal, potentially, if not dealt with. if you don't have the understanding of what they are, if you're living in a world that's totally void of their understanding, you have no ability to counteract. Oxygen and carbon dioxide. Two individuals here. Again, don't need to know the individuals, but know that this is something that's happening during the time period. Oxygen, of course, what we breathe. Carbon dioxide, what we exhale, also very critical to the plant cycles that we experience and the maintenance of the atmosphere and so forth. That has to get documented. Once you have an understanding, that sort of language, terminological foundation, you can then explore it further. I want to illuminate for you another one of these short little stories here on the discovery of oxygen and how a scientist thinker, Joseph Priestley, was able. Here's the big takeaway from both of these instances. The discovery of microbial life and oxygen, by no means are these the only breakthroughs in biology and chemistry. Please don't think so, but they're two big ones. And ultimately, it's important to recognize that these are the basis for all future inquiry and future investigation. Think of how much of our own world today is based on just those two things. Treatment of disease. You can't treat a lot of disease if you don't have a thorough understanding that there are microbes out there and that they exist and they can take different forms and they can become immune resistant and all of those other things. The sanitation facilities that we have, water treatment, food preservation. How best to do that, how to avoid things from becoming rancid and rotten and things that can make you sick. Even something as seemingly advanced as space travel, that is not going to happen if you can't isolate and capture oxygen and carbon dioxide and apply it in various mechanical forms. That's just not going to be the case. So when we say scientific revolution, that's what we're talking about, is it lays the basis for all of this future discovery. Another and final category that we're going to get into is medicine and philosophy. The one example of medicine that I'm going into, because this could go in many different directions, and is the principle of inoculation. One individual is going to be credited with this, more so than any others. The idea was kind of loosely circulating out there for long periods of time, but it's an English country physician named Edward Jenner, just a country doctor who is pretty learned for his time period and is reading and writing on a variety of topics, but his day job is a country doctor. And he has the idea that, first of all, his life is deeply informed by the presence of death and disease really at every turn. And one of the most common killers in England in the 1700s would be smallpox. Lots of people would have gotten smallpox, many people would have died, others would have been disfigured. It was part of everyday life. In terms of, just think about everyday trauma, I think I mentioned in a previous lecture that if you go back to the age before antibiotics, death is really around every corner for a lot of people, as it was in Jenner's time. And he notices that certain segments of the population tend not to get smallpox. He notices that these happen to be milkmaids. Women who tend to work around the milking of cows and the transporting of that milk. He notices that this may be because, he's hypothesizing from his observations, because they encounter a lesser form of pox known as cowpox. And perhaps, Jenner surmises, that exposure to cowpox builds up some sort of immunity to smallpox. So I want you to kind of see the story. In a way, this is a very optimistic story, the story of Jenner and inoculation, in the sense because it's one of those Enlightenment scientific revolution stories where people were faced with a very real problem, death from smallpox. A country doctor who's constantly interacting with this reality is observing the world. He's starting from that premise. He's not necessarily projecting anything new on it. He knows some background knowledge, and he has an opportunity to run an experiment, and he does. And he can demonstrate that principle of inoculation, and other people can replicate it. So it's not as though this is, the whole basis for modern medicine, but it demonstrates the fact that someone can observe a phenomenon, run an experiment, and arrive at a greater truth as a result. And that's a very optimistic way to approach the world, and that's really what the scientific revolution is about, is this idea that you can comprehend, you can figure out the mysteries of the natural world through experiment, not from projecting previous ideas on a problem. We're going to get away from medicine here, and I want to close with kind of 4 philosophical shifts going on. These are kind of big trends. I'd really call your attention to these because they really touch on everything related to the scientific revolution. In philosophy, and philosophy was kind of a interwoven with science in this time period. People who considered themselves scientists would also be philosophers. There's a lot of like dual engagement with both things. Observation and experience is the most reliable path to knowledge. This is a big shift in philosophy during the scientific revolution and later on the Enlightenment. The idea that you should discount things that can't be tested or proven, the things that claim to come through divine inspiration or supernatural explanations, that is to be kind of like not engaged with, and that you should focus on what can be tested. That's a big shift. That's a big shift because if the intellectuals, if the scholarly community in your society is thinking this way, they're probably going to arrive at more truthful, applicable conclusions. One of the big proponents of this, we don't have time for the clip on it, is the Scottish philosopher and writer David Hume. Hume is going to argue that knowledge is only valid if it comes in through our senses and it can be tested. Here's a second thing. Knowledge should be open to everyone. We kind of saw this when we saw that model of the solar system device that was carried around during Newton's time. This may seem small, but it's a very big leap in terms of how humans see the world. If you go back to the Middle Ages, knowledge was a very cordoned off, separated thing. It was kind of decoupled from the rest of society, where educated, learned folks would engage in it, but it wouldn't be diffused to everyone. If you go to the scientific revolution, if you've got an idea, if you've got an observation, and you can run an experiment, you're good to join this game, so to speak. And that's going to be invited. Knowledge should be open to everyone, and it's very participatory. And if you conclude that, you might conclude that human beings have a lot more potential than you previously thought. This is a very deep concept, a philosophical shift in the way people thought. And that is, during the scientific revolution, there was a lot more belief that human beings have the potential for tremendous good. It doesn't necessarily say they're naturally good or they're naturally evil, but they have potential. There's a belief in the educability of the common person. It may seem like nothing to us today because we take it as so reflexive in our thinking that, of course, you want to raise someone in a good environment, you want to give them an education so they can develop to their full potential, rise to their abilities. It seems so natural to us. But if you have a very fixed view of the world that doesn't have that optimism on the average person, think of how many people are just not going to have access to their potential. This is going to be very much in the writing of Locke and Rousseau, John Locke and Jean-Jacques Rousseau, an English and a French philosopher. Finally, the belief that governments are based on consent. The idea that if whoever wields power in your society, whether it's a king, a parliament, some combination of both, that there's a form of consent there going on, and that if that source of power is not abiding by the deal, the contract that they set up, that there's maybe a threat that their power should be disrupted and dislodged. Final slide here, and you do not need to get everything underneath it. You don't need to get the subpoints. I just want you to get the major ideas here. In addition to those breakthroughs in the arrangement of the universe, biology, chemistry, medicine, and philosophy, I want you to think about something else that's happening simultaneously. You have a little bit of experience in this in US 1. This is the age of European exploration. This is the age of what used to be called the Spanish conquest. This is the age of Columbus and Magellan and the Spanish conquistadors, Pizarro, Cortez, and the conquest of Central and South America and the Caribbean and the creation of kind of New Spain. Spain is going to be the first to really aggressively pursue this, but others like Portugal, Britain, France, the Netherlands, they're all going to be engaged in it later on. Some big trends, consequences of this is that huge sums of wealth are going to go back to Spain. It's going to do a couple things. First of all, it's going to make the Spanish crown very wealthy. It's going to also tick off a lot of inflation as tons of new gold and silver coins come into circulation. But also the Spanish are going to kind of spend most of it on wars of religion, and not just the Spanish, but other groups as well. And finally, this is going to shake up power arrangements in Europe. If you're a monarch and you suddenly get a lot of this wealth from the New World, you're going to use it to kind of build up your power base in your particular country. Second big trend. The power of monarchs is going to grow. If you've gotten into the Renaissance reading, please do not pack up. We got 4 minutes. If you have if you're a monarch and you have a system of nobility and aristocracy that you're looking over, this newfound wealth from the New World is going to really strengthen your position. So we're going to see the rise in the power of kings and monarchs over the nobility. They're going to get the upper hand. They're going to get new technologies as well. The reading talks about this, that kings are going to come out of this era of exploration in a much stronger position. Thirdly, the European settlement. This is the era when Europeans are going to travel to the Americas, settle, and they're going to be locked in a real power struggle of dominance. Which European nation state is going to dominate the spice trade, the colonies in the America? Who's going to rule the high seas? Who's got the stronger navy? All of these sort of great power struggles are going to play out. And finally, perhaps most importantly, the Columbian Exchange. You should know this term. I think you got some exposure to it in US 1. The Columbian Exchange is the movement of plants, animals, and disease between Eurasia, that's Europe, Africa, and Asia, and the Americas. I have a bigger picture of that slide off to the side there on the next slide, if you want to see some of the specifics. But this is the transfer of all of those biological particulars between the old world and the new. So you're going to see a big shift in how people live. Europeans, in many ways, are going to come out on top of this because they're going to get the very calorie-dense food from the America and not be susceptible to the disease that the Native Americans will fall victim to. Here are some of those examples. So, just to sum up here, all of these trends are going to happen in conjunction with the new European scientific revolution happening. With that, if you have any questions, please make sure you check the notes.